Hello there. In this video, we'll be learning about one-sided limits. So first, recall that the Heaviside step function is given by h of x with this piecewise function out here with its graph shown below. So if you don't know this one was mentioned in the first video in this playlist on limits and continuity. So if you don't know that one, I'll probably link that video around somewhere in this video. So in here, if we try to find the limit of h of x as x approaches 0, observe that from its left side, out here, the values from its left side is given by 0. Since we have here h of x to be 0 for x less than 0. Now for its right side, observe that the values from the right of x equals 0 is given by h of x equals 1. So therefore, there isn't really a definite answer for this limit. So we can conclude that the limit of h of x as x approaches 0 does not exist. So that is the limit of a Heaviside step function as x approaches 0. But what if we are only concerned and we only want to observe the behavior of a function as x approaches a, say 0 in this case, from only one side, so either the left side or the right side? What if that is only our concern? This is where the concept of one-sided limits come in. So one-sided limits are limits that deal with the value of a function as x approaches a value, say a, from either the left side or the right side. We denote this by this one out here and this one out here, wherein this one on the left refers to d. This refers to the limit of f of x as x approaches a from the left, while this one on the right refers to the limit of f of x as x approaches a from the right. So the a with a minus sign out here represents the values of x less than a, or from the left of a, while this a with a plus sign out here refers to the value of x greater than a, so from the right side of a. So these are the two notations that we need to remember when dealing with one-sided limits. As an additional information, take note that if these limits aren't equal, we can conclude that the limit of f of x as x approaches a does not exist. So this one is a good indicator to show that a limit exists or does not exist. So with this in mind, let's try out some examples applying this concept out here. So let's have this first example. This one is the Heaviside step function that we had earlier. Before we start answering this one, feel free to pause the video so that you may try these examples out on your own. Okay, so let's start. So from earlier, we know that the limit of h of x as x approaches 0 is given by this one, so it does not exist. Now what if we are only concerned with the one-sided limit? So what about if we are tasked to find the limit of h of x as x approaches 0 from the left? So from the left of 0, so we know that this part out here is x equals 0. From the left, the function is out here. So the values out here is 0, since we have here h of x equals 0. Therefore, we know that the limit of h of x as x approaches 0 from the left is 0. Similarly, from the right, so we deal with these values out here. So from the right of x equals 0, we have this function out here which we know to be equal to 1. Therefore, the limit of h of x as x approaches 0 from the right is 1. So that is how we get the one-sided limits. Observe here that clearly, since these two are not equal, the limit does not exist. So it agrees with the additional note that we had a while ago. Let's have this second example. So for this one, what we have here is a graph of a crazy function out here. So there's a lot of lines out here. But all of this represents f of x. It's just piecewise if we view it. So let's first focus on the values of x as x approaches -4. So this part out here. Let's try to find its one-sided limit. Observe that if we observe the values as x approaches -4 from the left, or values less than -4, it's this line out here. So as x approaches -4 from the left, we have this one out here. So what is the value out here? We have -4. So therefore, the limit of f of x as x approaches -4 from the left is -4. Similarly, from the right, it is this one out here. So the value out here is 3 out here. So I hope that this can be seen, since I think the text or the character is quite small, but this one is 3. So we know that the limit of f of x as x approaches -4 from the right is 3. Since these two are not equal, we conclude that the limit does not exist. Clearly, it does not exist since there isn't a definite value when x approaches -4 for f of x. Let's move on to this next part out here for values as x approaches 1. Now in here, feel free to pause the video, since by this time you have a great idea already on how to answer these types of problem as seen in this part a while ago. So again, feel free to pause the video. Okay, so let's start. So let's start with the limit of f of x as x approaches 1 from the left. So from the left, we have this part out here. So as it approaches 1x equals 1 from the left, we have here y to be -3. So we say that the limit of f of x as x approaches 1 from the left is -3. For the right side, it's represented by this one out here. So clearly, the y value out here is 0. So we know that the limit of f of x as x approaches 1 from the right is 0. Since these two are not equal, we say that the limit of f of x as x approaches 1 does not exist. So I hope you got this one correctly. So let's now move on to the last example. The last example for this example number 2, to be exact. So in here, what happens when x approaches 6 for this function? Observe that from the left, it goes beyond infinity, goes up. So infinity and beyond out here. Although we haven't discussed the concept of limits at infinity or infinity limits, since there is no definite value out here, it just goes up as x approaches 6 from the left, we say that the limit of f of x as x approaches 6 from the left is positive infinity. And from the right, observe that as x approaches 6 from the right, f of x goes infinity and beyond, but downwards. So this one out here represents negative infinity, since it goes to negative values but goes down and down. So we say that the limit of f of x as x approaches 6 from the right is negative infinity. And again, since these two are not equal, we say that the limit of f of x as x approaches 6 does not exist. So I hope you got this one correctly. And so that is how we analyze the one-sided limits as well as the limits given a function. More specifically, a graph of a function. To end this, we have one final example. In this case, we don't have any graphs and we are only given with a piecewise function. So again, feel free to pause the video so that you may try this one first on your own. Okay, so let's start. So in here, our goal is to find the limit as x approaches 2 of f of x. So to do this, we'll first get the limit from the left of 2 and from the right of 2. So first, for the limit as x approaches 2 from the left, recall that the values from the left of 2 are values of x less than 2. So these values are x less than 2, which is this one out here. So we know that the limit of f of x as x approaches 2 from the left is simply this function out here. So we have 5 minus 3x squared. And since there won't be any problem when we plug in 2 out here, we can do direct substitution like how we do normally in normal limits. So we have here 5 minus 3 times 2 squared, and this will give us, when simplified, negative 7. Similarly, for the limit of f of x as x approaches 2 from the right, recall that 2 from the right means values of x greater than 2. So it's this one out here. So we have the limit of f of x as x approaches 2 from the right to be just the function 3x minus 4. And again, since there won't be any problems when we plug in 2 out here, we have 3 times 2 minus 4, which simplifies to 6 minus 4 and 2. So we have this one out here. Since the limit out here is not equal, we conclude that the limit of f of x as x approaches 2 does not exist. And so that is how we apply the concept of one-sided limits. Now, to formally end this, here's an exercise that you can work on. So in here, we are tasked to find the limit of f of x as x approaches -2 from the left, -2 from the right, 3 from the left, and 3 from the right, given this piecewise function out here. So to solve this, the idea is similar to the last example that we have. So in the next video for this playlist, we'll be dealing with harder examples wherein the idea on one-sided limits and its essence shines more, especially when we deal with radicals, with integer functions, with absolute value functions, and so on. So yeah, I hope you enjoyed this one. Feel free to comment down below any comments, suggestions, recommendations that you have for this channel in general. So yeah, that's it, and that's all for this video.